Right, let's get started. So today is OOP in Python. Woo. So my plan for today is to go through the health potion and weapon with game item and player. Go through that example as much as I can in the time we have, and mostly just explain some Python stuff along the way. Do a little bit of review of 1.15. And then kind of expand, take what we've learned in 1.16 and apply it to Python. And just have some fun in Python in a pretty relaxed environment. Since it's an open-ended coding thing, as always, if you have questions, something you want to see in Python, let me know. And then Friday is the You Decide lecture. So first, course evals, just so I don't forget. The progress is really slowing down. We got to 77, but it's looking less likely that we'll hit 80 before Friday. So hopefully y'all got application task 1 in before that deadline and the extended deadline. You had multiple chances already, so hopefully y'all got it in. And it's looking very dire that we're going to get 90%. I doubt that we'll get 90%. The last 23% of the class, they're just not doing anything anymore. So unfortunately, we might not get to 80%, especially by Friday. We only have 2 days left, so it's looking like that's where it's going to be. And then the vote on topics for Friday, the clear winner was Jesse and Paul fight. So yeah, we're kind of held to what we put out here. So we're of course not going to physically fight. I don't know if that's exactly what you wanted, but we will have a competition, which is going to be, despite what this one says, due to our schedules, we can't make all 5 lectures, so we're not going to do things in all 5 lectures. But in this lecture, so you're one of the lucky ones in this lecture, we'll do it, and at Paul's noon lecture in Cook. I always forget the room number, but the lecture hall in Cook. There's only one lecture hall over there. So noon and 2 are going to be our times for that one. We're going to have a series of events, which I had to pull up my cheat sheet in the previous lecture. I'm just going to pull it up right now. I don't remember what the events are. The first is going to be a costume contest, which I'm not looking forward to that one. The TAs chose most of the events. Actually, technically, they chose them all because they suggested the other one. So costume contest between me and Paul, obviously. And then Mario Kart, Just Dance, and Wii Boxing. So we're not going to physically fight, but we will do some Wii Boxing with the controllers and get that in there. And then the main event will be a rap battle. So if you wanted to see us, put out some really cringy lines, if that's what you wanted, which apparently is, because that's what was voted for, and the rap battle got a lot of traction here. That's what you get. That's what we're doing. And then the other 2 lectures, I guess it doesn't matter to you since you're in this lecture, but the other 2 lectures I'll be doing other things. Since Paul can't make those 2, I'll do whatever they want to do in those lectures. Yeah, so that's what we're doing Friday. It's happening. And then that takes us to the final exam. So I think that's all I need to talk about in this lecture. I have a lot to say in the other lectures because they're not getting the competition in their lectures. For this one, you're getting the competition, so just show up to lecture. All right, so let's just go for this. Which the TAs are very much looking forward to the rap battle. Paul and I are not as much, but it'll be fun. So let's talk about Python and do some things in Python. Oh, and since some of the sections they aren't having this in theirs. I don't know how many people are going to show up, but I would make sure you get your seats just in case it does fill up. Hopefully it doesn't. I hope no one shows up and then we don't have to do it. But anyway. Keep that in mind that other people, especially the TAs, they're going to be here, so at least those seats are going to be filled up. It won't be empty like it is right now. So, talk about Python. So this is PyCharm. So in 1.16, we used IntelliJ all semester. IntelliJ was an IDE that is primarily designed, it was designed for Java code, and there are other languages you can use IntelliJ for. You can program like Scala, we used to do Scala as well, Kotlin, a few others. You can even do Python in IntelliJ these days with IntelliJ Ultimate. And then there was a community edition, and then with your EDU license, you get the Ultimate edition for free. PyCharm is the same way. It's made by the same people, JetBrains. It's the same organization, releases PyCharm, which is the same thing, but for Python. So it's basically IntelliJ for Python. It's tuned to work with Python code, and it has a community edition for free, and with your EDU license, you can get the Ultimate edition. JetBrains also makes IDEs for pretty much any language you're going to work with, and all kinds of other tools that aren't even IDEs. They make a lot of products. Personally, I like their products, but they make good IDEs. But there are other ones. WebStorm is the next icon over here that you've seen all semester in my tray here. WebStorm, of course, for building web apps, primarily focused on JavaScript and HTML, CSS, all the web technologies. It does a good job of working with that. And there's also CLion. I don't have it installed here. And this is where I try to piss Ethan off. CLion is an IDE for C. I believe it does C++ as well. But for C, relevant for 220, CC 220, you're going to learn C. And Ethan's going to tell you to use Emacs, and he's going to swear up and down that Emacs is the only way to write code. Emacs is a straight-up text editor that you have to use in the terminal. So it's tough to work with. If you like the IDEs, if you've enjoyed IntelliJ this semester, despite its drawbacks like taking up all your RAM and CPU whenever it wants, CLion is the one JetBrains makes. That and WebStorm, I believe, don't have free community editions, so if you didn't set up your EDU license, you do have to set that up to use those two IDEs. So use CLion, and when Ethan says, "What the hell are you using here?" make sure you tell them that Jesse told you to use that, and that's the best thing ever. So just so he gets mad at me, because he'll have you. I don't know. It's a big step going from a full IDE to a text editor. I don't think there's ever a reason to make that step personally. I have VS Code. I'll use VS Code sometimes, but there's no reason to when you have IDEs available to you. I don't know. That's my opinion. But if you don't like the extra help from an IDE, go ahead and use the text editor. But this is PyCharm, IntelliJ for Python. And I'm going to click New Project. We're going to start right from the beginning. And it's going to give me a default name, Python Project 1. I'm going to call it Python Project 2 PM for the 2 PM lecture. And I'm going to use the defaults here. It's going to set up my Python interpreter and everything. I'm going to use Python 3 for this. And hit Enter. Since I have my font blown up so big for the projector, I can't get to my button, but I'm just going to hit Enter to start the project. And it's going to give me some starter stuff. I'm going to delete all this, but we are going to recreate mostly, a lot of what was there that I deleted, but I want to explain it as I write it. So we want to talk about Python again. So let's do a little review of Python the way you saw it in 1.15. This is probably how you wrote code a lot, and throughout a lot of 1.15. You do like x equals 10, x equals x plus 8. Something they shouldn't have shown you, but you might have used anyway, is plus equals is a little bit of a shortcut. And then you would print x. You might have a function, def half it. Let's do x again. I'm going to reuse a variable. It's going to give me a warning because it doesn't like me reusing a variable name like this, but our scoping rules are going to kick in and it's going to be fine for us in this case. Half it, return x over 2. Print x equals half it of x, and then print x. And then if we want to run this, we're going to right-click our file and run just like we did all semester in Java. And we're going to get quite a few things going on. We're going to print x. When we run this file, it's going to be ran as a script, which means it just runs all the lines of code in this file. It just runs all the code that you have in the file. We're going to define a function, run each line of code one at a time, and then when we get to the end of the file, that's the end of the script and the program ends. We're also going to have an int. X is an int. Let's even run this in the debugger. X is an int, but as soon as I divide it by 2, x is going to change to a floating point value. I don't declare a variable with a type. We don't have static typing in Python. Everything is very loosely typed, I think is the term, where the type can change. So the type of the variable x didn't matter. It changed from storing an int to storing a float, and that's just perfectly fine in Python. I divided by 2. I didn't get integer division like I would get in Java. Even though I didn't put a 0.0 here, it just said, oh, there's a decimal portion. Let's do that decimal portion. For what it's worth, if you do want integer division, you put two slashes, and you will get the integer division. So you still have that available to you. Like last time, we wanted an indice, so we wanted to take advantage of integer division. We can still do that, but by default, you're going to get the floating point value. And when I run this, well, compared to a Java program, all semester, you hit run, and you wait. You wait, and then your code finally starts running. That was the compilation process. That was the difference between compilation and interpretation. Since Java's compiled, when you hit run, it doesn't just run your code. It compiles all of your code into Java bytecode and then runs the Java bytecode. With Python, it's interpreted. It just straight up runs line for line. So when I hit run, it runs. It just goes immediately. That's something you kind of miss from 1.15. And that wasn't an IntelliJ thing. That wasn't a 1.16 thing. That was a Java thing because Java is compiled. That's why we have that delay. You have the progress bar on the bottom every time you run your code. That's the compilation process. And then your code can run. And your code runs usually faster in a compiled language, but it doesn't get to run until that long delay of the compilation process. So there are trade-offs. The big one, or I shouldn't say the big one. So the big one that you felt all semester is waiting before your code runs. But then when it runs, I just said that, didn't I? But then when it runs, it usually runs faster. But also the compiler did a lot of checks for you. The compiler is constantly looking over your code, and IntelliJ, with something called IntelliSense, is always looking at your code as though it were the compiler to see if there are any errors in your code. So for example, if half it, instead of giving it x, I'll give it the string x, it's going to give me a warning because PyCharm's looking out for me and saying, hey, I don't think that's right. But I'm not getting an error. I'm not getting any red squiggly lines. I'm not getting anything that looks overly scary here. We get warnings for all kinds of things. It's just another warning that says something, string doesn't have a true division method. But I got another warning up here. It doesn't like me using the variable name x. Like, so what? I got another warning. It's not an error. But then when you run your code, well, it actually is an error. The compiler's not going to let you make a mistake like this. The compiler's just going to say, hey, yeah, you got an error. You got to fix that before I'm going to touch your code. So Python's not going to do that for us. Being an interpreted language, you don't get an error until it runs the line of code with the error, unless you have a straight-up syntax error. Like this would be a syntax error. I'll get a legit error because you can't have an empty code block. But this is going to be a runtime error. So that's a reminder of the difference between interpretation and compilation. Hopefully a quick refresher on Python syntax. So now let's get into some new stuff. Whoa, I'm in Wholesome Images lecture. So now let's get into some new stuff. So this is how you would write code in 1.15. Usually you write it as a script. But we don't always want to do this. We don't want our code to run just hanging out in the middle of nowhere. what we'll do is the same thing we did in Java. We're going to write a main method, or main function in this case. So to do this, we're going to write if name equals main. I should have just let IntelliJ type that for me to make sure I don't have any typos. Looks like I nailed it. And then have all our code inside of that block. And I'm going to take this a step further. So this is going to check if some special variable called name, which is the name of the, I don't know the generic what this is, the name of the module, I guess. And if this is the file that's being executed, this is the one that the user said, hey, Python, run this file, then name is going to be main. If it is not the file that the user said, hey, run this file, then the name is going to be the name of the module in which it's in, which is the name of the file that it's running. So we check that name, we check this special variable, and if this is the file that's being ran, then run this code. But if this is not the file that's being ran, don't run this code. I said I'd take it a step further, and then I got sidetracked. I'm going to take this a step further and define a main function, put all my code in that main function, and then call main in my conditional. So now I'm calling this function if name is main. And putting in a separate function, it helps me keep my code organized, and if I want to call this function, even if this isn't the code that's being executed, this isn't the file that I said run this file, I can still just call main from anywhere in my program. Because maybe I want to call this twice, maybe I want to call this when it's not the file being ran. There might be a lot of reasons why I want this set up like this. Whereas if I put all my code here, the only way to access that code is to run that file. So this gives me more options, gives me more flexibility down the road. And as we get more files, I'll circle back to this main method thing and explain why this was so important. I'll just circle back to it. You wouldn't do this in 1.15. The big difference is we're going to have, actually, is this even true? We're going to have a multi-file project. But I think that was true for your project in 1.15. You had a multi-file thing. Did you use main methods? Okay. So you did have multi-files, but you didn't use main methods. Okay, good to know. So I'm still showing you something new at least. But we're going to have multi-files. So let's create our next Python file, and I'm going to call this game item. And I'm going to create a game item class. Let's move into 1.16 territory and start talking about some new stuff. So to declare class in Python, starts off simple, not simple enough, but similar enough to Java. Class, game item. And then that starts a new code block, and I'm going to start defining the game item class. I can create variables and methods in here, and now they are going to be methods because they're part of the game item class. And there's one very special method with a very special name, init underscore init underscore. Python loves its underscores. I'm sorry, I can't. There's nothing I can do about it. And then takes a parameter usually named self. And for now, I'm just going to leave this blank, which pass is my favorite keyword, by the way. It means do nothing, but since in Python you can't have an empty code block, if I want to stub out a code block, just use the keyword pass. Say, this is an empty code block. So what this does is gives me a constructor. So instead of explicitly calling the constructor game item, we use init in Python. And then when we call the constructor, we do it the same way we did in Java. I'm going to say game item as the constructor name, but this is how you define a constructor in Python. And then if you want instance variables, let me talk about self. So in Java, we had this all over the place, and this was always invisible, kind of. Like it kind of just comes out of nowhere. It's just there, and you can use it. But it is actually a parameter of every method that exists. Python makes this more explicit. It says, no, if you have a method, your first parameter has to be a reference to the calling object, or in the case of a constructor, the object that's being created. Just like this, but it has to be explicit. And this is just a variable name. I can call this whatever I want, but generally we stick to convention and call it self. We can even get cute with it and call it this, but actually Python didn't like that. Is there a reason? Usually the first parameter of the method is named self, but it is a variable name, so you can call it whatever you want. But stick with self. If you do something other than self, other developers are going to read your code and say, what the hell is going on here? So just stick with self. To declare an instance variable, I'll circle back to that, self dot the name of your variable, wait. And you can't just declare a variable like you can in Java. We didn't really do that much this semester, but you can't just declare a variable. You do have to assign it as well. So I'll have to give this some default weight, and let's get, oh my goodness, description with some default description. So there's a temptation in Python, if you're coming from Java, which you all are. You've done OP in Java, and maybe you've done OP in Python, but if you're just following the courses 115, 116, you haven't done OP in Python, there's a temptation to want to put your instance variables up here where we put them in Java. It just makes sense. And do something like, well, let me use a different variable name. Type. That's reserved. How about cost? I think that's what I used in the other lecture. Like cost, and then give it some default value for cost. You'd be tempted to just create your instance variables like this. This is not going to give you an instance variable. This is going to give you a class variable, which is equivalent to a static variable in Java. So if we said something like GameItem.cost, we can access that variable right through the class itself. I'm getting a warning here, but that's only because I'm not using the value of that variable. So I can access that variable right through the class itself, but not through objects of type GameItem. It belongs to the GameItem class. If I want instance variables that are associated with each instance of the class, I create them in the constructor using self dot. That's how I create my instance variables. So weight and description are instance variables associated with every game item object, and cost is a variable that's associated with the game item class. Okay. And we'll come back to this one and add some more functionality here, but let's get the rest of our setup. Let's start with weapon. Get my init. I'm going to stub it out for now. And what we want is to inherit from GameItem. So one, Python, and I haven't done OP in Python for a while, so if somebody wants to correct me on this, but I'm like 99.7% sure. There's no abstract class and there's no interface in Python. You have concrete classes. Thanks. I'm up to 100% now. And there's no interface, no abstract class, no abstract methods. None of that exists in Python. You got concrete classes or you got nothing. No OOP at all. So we created this as a concrete class. And then when we want to extend that class, when we create a new class, we're going to use parentheses right after the name of the class and then put the class that we're extending in those parentheses. So this is read weapon extends game item, and now we have all the functionality from game item in the weapon class. And I'm going to get an error. Unlike Java, that will everything in the same package is auto-imported, we do have to explicitly import game item. So import game item, which won't work for us, is going to give us the game item module. And then if we want to create if we want to create objects of this type, let's get a main method here. Let's go def main. main. And then to create an object of type weapon, which again isn't going to work, but I'll explain that. Create a variable equals, and then it's very similar to Java, except we don't use the keyword new. We just do weapon of, and let's give this a parameter, weight. And let's create a 15-pound weapon. And let's print weapon dot, oh yeah, we don't really have anything yet. Let's do weight. And run this. And we're going to get this error. Module takes at most 2 arguments, 3 given. And this can be a real head scratcher if you don't know what you're looking for, if you didn't write this error on purpose, which I say that to make it sound like I know what I'm doing, but I made this mistake on the previous lecture, but now I'm making the same mistake on purpose, so I can talk about it. So when you import a module, which is very different from Java, you're importing the entire file. And unlike Java, where with Java, a file corresponds to a class or an abstract class or an interface, it corresponds to one thing, one class, and that's it. That's not true in Python. I can have another class here, that I'm going to call another class. Def init, pass. I can have a method up here. I can have a variable up here. I can print that variable to the screen. I can put any code I want in here. Just like in 1.15, where you write these scripts that have all kinds of code, you can just have a script, and then it happens to have a class or two defined in it. So when I import GameItem, I'm importing that entire file. I'm importing every method, every class, every variable, everything when I import GameItem. In fact, I can do GameItem.myVariable. I can access that variable. I can access that method and call that method that I imported. I get everything in that entire module. If I don't want everything in that module, actually, let me do something else first. So let's run this. We can actually do GameItem.GameItem. Let's do it this way first. GameItem, the module, and then I'll get the GameItem class from that module. So now I'm extending the GameItem class, not the GameItem module, but I'm using my Java naming convention still, where the file name matches the class name, which is why I got into trouble like that. And then I'm going to get a warning here. We do have to call the superclass constructor still. This has to be explicit. So super, and what I missed in the previous lecture, with parentheses, because I don't know why. And then the constructor, and that's it. It's going to give us a default weight, and then I'm going to have a self.weight variable already, and let's reassign it the value weight. And let's also print out weapon.description and run this thing and see what we get. So we printed out the weight. We got 15 as the weight, and we got that default description. If we want to override our default description, that's just to prove that we are inheriting this variable. Because if we do description like we're about to, self.description, even if we weren't inheriting anything, it would still work. But now we verified we're inheriting it, and let's do weapon. Rerun this, and we overrode that variable's value. But I'm getting 1010 printed to the screen also. Because when I imported GameItem, when I import a class, when you import a module, all of the code in that module is executed. Now, usually we want that because we're defining our methods, we're defining our classes. We want all this definition, we want all this stuff here. But it also runs any lines that are not in a method or class. So these lines of code were executed. We got 1,000 printed to the screen. And this line of code was executed, and we got 10 printed to the screen. So whenever you import a class, any code that's not in any methods is going to be executed. And this is why we set up our main methods the way that we did. That's why we set up a main method like this, because, and let's reorganize this a little bit. Def main main format, and run this. Now those lines are not going to be executed, because if we set a breakpoint right here, and let's run this file, we can look in our debugger at what the value of that special variable name is. And here, name, we can see, is actually underscore underscore main underscore underscore, because this is the file that was ran. Since this is the entry point of our program, we're going to get name equal to main. But when we import that class, so now I'm running weapon, which imports, I didn't click on it, which imports game item. Now, when we're in the game item module and we're executing all of this code and we get to this conditional, which is at the top level of our module, this conditional is always going to be checked, whether we're importing or running this thing. Now, name is going to be equal to the name of the module, which is not underscore underscore main underscore underscore. Therefore, this does not get executed, and we just move on with our lives. So the main method, set out main like this, is a way to have this code only executed when this is the entry point of our program, which lets us put like some debugging checks here. We can write some of our kind of fake testing in these main methods. Any code that you want to run when you're testing that class or running that class directly, but not when you're running your entire program. That's going to go in a main method, so it's not executed when you import that module. So when you're developing in Python and you hear all this stuff about main methods, hopefully that clears it up. And you can know why we use this main method in the way that we use it. So let's clean this up. I don't like this GameItem.GameItem here. So let's clean up our import. Let's finally circle back to this one. And I'm going to say from the GameItem module, import the GameItem class. And now I can just use GameItem like it's a regular class. This is going to get me what I want. I still get the same behavior, but I clean up my code a little bit by being a little more explicit about my import, about what I want to import. Oh, I meant to do this. I did this a little out of order. Let's do this. But even when I'm only importing that one class from the module, the entire module is still executed. Everything is still ran. So if I have any code that's outside of the main method, this doesn't get rid of that. It still runs all the code outside of any of the methods, but it cleans up my syntax here. So this is still executed, even though I'm only importing the GameItem class. This line of code is still executed. This check still happens. All that stuff still happens. Now I put that back in my main method. Now we're clean. Okay, let's copy weapon. Let's get our potion right quick. Potion. Get rid of the main method completely. We won't test potion at all. And I got a potion class too. Not much to say about that. It's the same thing as the GameItem class. But now let's go back to our main, which is going to be the entry point of our program, and start. Let's get a player class too, so we got more to work with. Player, class, player, def in it. Self.inventory is going to be initialized to an empty list. Def add to inventory item self.inventory. And I believe the self is not optional in Python. Let's get the rest of this line and confirm. Yeah. So the Python developers do agree with me that just always be explicit about what you're doing. Def use all inventory items for item in self.inventory, item.use of self. And then in the game item class, we don't have a use method. So in the game item class, we're going to need I say need quite loosely here. We're going to need a use method that takes a player. And notice, I don't think I mentioned this in this lecture. All the lectures always blend together for me. But the first parameter always has to be self for every method, not just the constructor. So self, and you can see that PyCharm is adding it there for me. I'm not even typing self. PyCharm is just adding that for me because it knows every single method, and it's a method because I'm inside a class, has to have self as its first parameter. So it's just adding them in there automatically. Now I want use to be an abstract method. I want this to be inherited from other classes, and I don't want any default behavior, just like the abstract methods that we saw in Java. So this is another use of pass. I'm just going to pass and have that do nothing. And then in potion and weapon, we don't have any concept of override here, especially, I shouldn't say no concept of override. The concept's still there, but we don't have any override annotation like I like, so we have to do things the Paul way and just be careful about the way we type things out. Use of player, and let's give player a few instance variables to work with. Self.max HP equals 100, self.HP equals self.max HP, self.attack power equals 1. And when a potion is used, we're going to say player dot HP. I forgot to mention this in the other lecture, but notice I am accessing instance variables directly, and that's an okay thing to do in Python. I forget the syntax for it. I probably shouldn't even bring it up since I forget. But there's syntax to add getters and setters after the fact, where the methods are called with exactly the same syntax as just assigning a variable or accessing a variable. I really should look that up if I'm going to talk about it in lecture. Yeah. What is it?
So what you're going to want to do is
Inside the constructor?
not in the constructor as a separate function.
So at HP like this?
Getter. I think it should be.
Let me see if PyCharm just does it for me, actually. No. But suffice to know that there is a way to do it. That's the important part. Where Java, there's no way to, after the fact, after people start doing player.hp equals, once people start doing that, you can't go back. You're screwed forever. You can't add a setter method after that. But Python lets you define a setter method after the fact where this syntax will not access the variable directly. It'll start using your setter method instead. Bless you.
So before you do make that setter, you have to define it as a property.
How do I define it as a property?
So type in the annotation at property as a separate thing outside of the initialization.
Def, like def HP
Def,
or space HP.
def space HP.
Then as a method.
And yeah, as a method.
And I would assume we'd have like HP here. Let's call this something different, just in case it's conflicting with things. What do I got wrong? Statement break expected. What do I got wrong? I feel like I typed what you said. Oh, I got rid of my... Oh, the autocorrect got rid of my variable. Does not take a variable? Statement break expected. All right, I'll circle back if you got the syntax. So some languages will let you add the getters and setters after the fact. Java is not one of them, so Java, when we're typing in Java, I'm always going to use getters and setters. Python, not going to use them. That's differences between the languages. I'm not just being lazy with this example. Well, there are some things where I'm being lazy with this example, but that's not one of them. Player.hp equals min of player.maxHP, player.hp plus self, and I'm going to say the weight of the potion is equal to its healing power. Then a weapon, we want to use method def use player, like here's one case where I'm going to be lazy, player dot attack power equals a whole bunch. Instead of declaring that as a constant or as a constructor parameter, I'm just going to say every weapon has 10 million attack power. Now, if we go back to our main method, let's create our player. Did I give any constructor parameters? No parameters here. So let's create our player. Player dot add to inventory weapon of 50, even though we don't use the weight at all. And player dot add to inventory potion of 20. And another potion of, let's say, 34. I'm going to get all kinds of errors because I didn't import anything. So from player, oh my goodness, import player from potion, if I can hit the right letter, potion from weapon, import weapon. All my errors go away, and then let's do player dot HP equals 5, so they've been in a rough battle. And then player's going to just go through their whole inventory and use everything. And let's print player dot HP, print player dot attack power, make sure we get the values we expect out of this. And run it. So 59, we got hurt down to 5, we healed 20 and healed 34. So 59 sounds good to me. And 10 million attack power. And we get 10.5 and 21 printed because we're printing them right up here. That's fine, I'm just going to leave them there. All right, so we have potion and weapon both extending game item. And then game item defining a method use and two instance variables with one class variable. But Python isn't strongly typed, so none of this really did anything. If we delete this, Everything still works. We kind of called that an abstract method, but there's no such thing as an abstract method in Python because there's no use for an abstract method the way Python does things, the way everything's loosely typed. So we don't need, in our player class, when we call item.use here, we actually don't need a guarantee that the use method exists, which is why we use inheritance and polymorphism in Python. In Java, we wanted to make sure 100% guaranteed that that method exists. If it's an abstract method, we don't know what it's going to do. It depends on the type of the object, but we know that it has to exist. But Python don't care. Python doesn't give a damn. Python's going to get to this line of code, go to the object referred to by the item reference, and try to call a use method that takes a player. Actually, it's not even going to check the type. That takes one parameter. And that's it. If that object has a use method that takes one parameter, it's going to be called. If it doesn't, we're going to get an error. So if we get rid of one of these, if we comment this one out, now we're going to get an error because the use method doesn't exist. But Python just lets you do what you want. And then if there's a runtime error, if it gets to a line of code that it doesn't know what to do with, then it's going to be an error. But not until that time. So the compiler's not doing any checks to make sure that method exists. It's only during runtime. So even when the method doesn't exist, like our other print statements are still printed, but once we get to this line, then things crash. But if we wanted some default behavior, like getting a default description like we have, if we want some default behavior from the game item class that we inherit, then that's where this becomes useful. But since we have no sense of types, or at least that types aren't strict in Python, there's really no sense of polymorphism either. That polymorphism just goes away. We still get the benefits of inheritance if we want to reuse code in different classes. But the whole polymorphism thing, like Python already lets us have data structures with mixed types. Hell, we can, in fact, we can get rid of the inheritance altogether. And this will still work. We can mix weapons and health potions in our variables, or in our data structures. Like, that's perfectly fine. It's a fine thing to do in Python. We do it all the time. So we only get inheritance, but not really polymorphism. Without typing, polymorphism doesn't make sense. I think that's good, unless there are questions. One thing